Hello, hypothesis testing about single population mean. Okay, now suppose assume mu A is a hypothesized or assumed population mean, x bar is the sample mean, and mu is the actual population mean. Okay, so mu is the assumed population mean, mu is the simple mu is the actual population mean. So steps of the hypothesis. First one, mu is the population mean. First of all, you have to decide the level of significance. Alpha is equal to 5% or 1% or 10% or anything. Okay. Third is we have to decide H0 and H1. H0 is the null hypothesis, H1 is the already hypothesis. For two-tailed test, mu is equal to mu A and mu is not equal to mu A. Okay, so for two-tailed test, for left-tailed test, so for two-tailed test, this one for left-tailed test, null hypothesis mu is equal to mu A and alternative hypothesis mu is less than mu A. For right-tailed test, mu is equal to mu A and mu is greater than mu A. So it is right-tailed test. Okay, then reject or accept the reject or do not. Okay, so before that, calculate Z statistics. Okay, so Z calculation is x bar minus mu sigma by square root of n, where x bar is the sample mean, mu A is a assumed mean, sigma is the standard deviation, okay, and A is the sample size. Now, assume sampling distribution is normal and level of significance is alpha, and under the null hypothesis, the test statistic is x bar minus mu A by sigma by square root of n. So this is called standard error. So here standard error of simple mean is sigma by square root of n. Now if sigma is unknown and if the sample size is very large, then we can write s by square root of n. Here s is the sample standard deviation. Okay, next, decision. So if it is, how to take decision? Okay, now suppose for two-tailed test, assume alpha is the level of significant, and so that means plus there should be z alpha by 2 value, z alpha by 2 value. So these are called critical values. Okay, so these are called critical values, and already you know how to get the critical values. So from the table value we can get the critical values. Okay, now you can see here. So for two-tailed test, if it is 5% significant, then it is plus minus 1.96. So here should be plus 1.96, here 1 minus 96 minus 1.96. If it is 10%, okay, so it is plus minus 1.654. So plus 1.645 minus 1.645. Okay, so you have to decide any one. So this one, if alpha is equal to 5%, here it is, if it is 10%. Okay, so if zcal value, if this zcal value is within minus 1.96 to plus 1.96, then accept H0 or do not reject the H0. Otherwise, if the value is somewhere here, say it is 2, 2.5 or less than 1 minus 1.96, say minus 2.04 or minus 3.8, then reject the null hypothesis. If it is right tail test, okay, so here should be Z alpha. So this is the acceptance region and this is the rejection region. So if Z is equal to if alpha is equal to 5%, then this critical value is 1.645. Okay, and if it is left tail test, then this is minus 1.645 if alpha is equal to 5%. Okay, so if alpha is equal to 5%, then this if alpha is equal to 10%, then this particular value is 1.28 and this particular point value is 1.28. Now, if zcal value, if it is two-tailed test, if zcal value, z calculation value is in between minus 1.96 to plus 1.96, if alpha is equal to 5%, then do not reject the null hypothesis. Then do not reject H0. If it is right-tailed test, and if the value is, if z calculation is more than z alpha, then reject the null hypothesis. Clear? In this case, if zcal is less than minus z alpha, then reject the null hypothesis. So here, if the value is somewhere here, then it is reject the null hypothesis. Okay. Now see some example. A sample of 900 members has a mean 3.4 centimeter and standard deviation 2.61. Okay. So example 1. If a sample of 900 members, so sample size is 900, mean 3.4 centimeter, mean is 3.4 centimeter and standard deviation is 2.61 centimeter. Is the sample from a large population of mean, for a large population of a mean 3.25 centimeter and standard deviation 2.61 centimeter. Okay, so question is, there is one population, okay, and its standard deviation is 2.61, it is known. There is a sample mean where size is 900 and standard deviation is 2.61, okay, and sorry, it should be x bar. Okay, so sample mean is 3.4. The question is, check whether this particular sample is from this population or not. So this is the population. Okay, so parameter of interest. So first of all, parameter of interest is mu, mean. Second is what? Alpha. Assume alpha is equal to 5%. Okay. Third, H0, null hypothesis. Now always it should be equal to, that means mu is equal to 3.25 and alternative is what? Mu is not equal to 3.25. Okay. Now under H0, the test statistic is z calculation is x bar minus mu sigma by square root of n. Okay. So x bar is what? 3.40. X bar is 3.40 minus mu is 3.25. Okay. 3.25 by sigma. Sigma is 2.61. 2.61 by square root of n. N is 900. So it is 900 and its value is 1.73. Okay. So we have to take decision with the help of the critical value. So z alpha is equal to 5%. So z alpha by 2, that is z 5% by 2 or 0.05 by 2 minus z 0.05 by 2. So its value is plus 1.96 minus 1.96. Okay. So from the table we can see this particular table. So if it is 5%, it is plus minus 1.96 and its value is 1.73. So 1.73 is somewhere here, it is 1.73. okay, so that means 1.96 is minus 1.96 is less than 1.73 is less than plus 1.96. okay, so do not reject the null hypothesis. That means we conclude that this particular sample sample from a large population of mean 3.4 centimeter and 2.61 centimeter. okay, so this particular sample is from this particular population. Now second example. A plastic part was designed to tolerate an average pressure of 100 units. Okay, so 100 units. A random sample of size 150 was tested, and it was found that the average pressure which these parts can withstand is 98 units. Okay, so x bar is equal to 98 units with a standard deviation of 10 units. Test that the lot meets the specification with 1% significance level. Clear? So parameter interest of is mu. Assume level of significance or significant level is 1%, that is 0.01. Okay, so alternative hypothesis, mu is equal to 100 and h1 is what? Mu is less than 100. Okay, so if the value of mu is more than 100, then it's no problem, but if it is less than 100, then it's a problem. So that's why we have chosen left tail test. After that, we have to calculate the z-cal. Okay, so the z-cal is x bar minus mu by sigma square root of n. Since sigma value is not there and the sample size is large, say more than 30, so you can write s by square root of n. Okay, so x bar is 98, mu is 100, sigma s is 10. Okay, so this s is 10 by square root of n, it is 150, and the answer is minus 2.4494. okay, since it is left tail test and alpha is equal to 0.01, so minus z 0.01, so you have to see the table value. So if it is 1%, and if it is left tail, minus 2.33, the critical value is minus 2.33, and your calculated value is minus 2.44, so minus 2.44 is somewhere here, minus 2.4494 is somewhere here. So this is the rejection region. Okay, so this is the rejection region, and reject the null hypothesis means reject the lot meets the lot doesn't meet the specification with 1% significant level. Clear? Next problem. Okay, third problem. The mean lifespan of a sample of 200 machines produced by Tata Company is 3000 hours with standard deviation of 350 hours. Okay, so sample size is 200, mean lifetime is 3000 hours, and standard deviation is 350 hours. Test the hypothesis with 5% significance level that the mean lifespan of a machine produced by the Tata Company is 2900 hours. Okay, so our parameter of interest is mean, alpha is 5%, h0 is mu is equal to 2900, and h1 is what? Mu is not equal to 2900. Clear? Now z-cal x bar minus mu by is by square root of n, because sigma is not known here and the sample size is very large. So x bar is 3000 and here it is 2900, s is 350 by square root of n. What is n? N is 200, and if you solve it, its answer is 4.0404. Since it is two-tailed test and alpha is equal to 5%, and already you know, sorry, it should be like that. Okay, so minus 1.96 plus 1.96, and calculated value is somewhere here 4.0404. so reject the null hypothesis. That means we can say that for two-tailed test at 5% significant level, the critical value is plus minus 1.96. Since the calculated value 4.0404 is more than the critical value, hence we reject the null hypothesis. Therefore, the mean lifespan of the machine produced by the data company may not be 2900 hours. Okay. Okay, next problem. An automatic refilling machine is about to pack 5 kilograms of wheat. A sample of 120 bags was examined to test the machine. The average was found to be 5.21 kilograms. So average was 5.21 kilograms with standard deviation of 0.20 kilogram, with standard deviation of 0.20 kilograms. Is the machine working perfectly? Assume the level of significance is 1%. Clear? So our aim is to know whether the machine is filling with the 5 kilograms of wheat or not. Okay. So level of significance. So parameter of interest is mu. Level of significance is 1%, that is 0.01. Null hypothesis, mu is equal to 5 kilogram, and alternative hypothesis, mu is not equal to 5 kilograms. Okay. Now under the null hypothesis, the test statistic is Z calculate is x bar minus mu by s square root of n. So x bar is what? 5.21 minus 5 kilogram. S is 0.20 by square root of n. N is, so total number of bags, here it is 120 bags. Okay, so 120, and its value is 10.9495. Okay, and 45. For two-tailed test, the critical value of 1% significant level is plus minus 2.58. So alpha is equal to 0.01. So minus z 0.01 by 2 plus z 0.01 by 2 is, here it is minus 2.58, here plus 2.58, and its value is 10 point, which is far away from this particular value. So reject the null hypothesis, and since the computed value is more than the critical value, hence we reject the null hypothesis and we conclude that the machine is not working properly. Okay. Okay. Now hypothesis testing, different of means. Okay, so steps of hypothesis. So first one is parameter of interest mu1 and mu2. Level of significance alpha. Okay, and H0 is mu1 is equal to mu2, and H1 is what? Mu1 is not equal to mu2 for two-tail test. For left tail test, H0 mu1 is equal to mu2, and for alternative mu1 is less than mu2. This is for left tail test. For right tail test, H0 mu1 is equal to mu2, and alternative mu1 is greater than mu2. Okay, then you have to calculate the test statistics. So under the H0 null hypothesis, that test statistic is z cal x1 bar x2 bar divided by where x1 bar and x2 bar are the sample means, sigma 1 square plus sigma 2 square are the population variance, and n1 n2 are the sample sizes respectively of the two population. Now different cases are there. Suppose, so this is nothing but our standard error, already we know. So x1 bar x2 bar and standard error of x1 minus x2. Now if case 1, if sigma 1 square is equal to sigma square by sigma, that is common population variance, then z calculation is what? X1 by x2 bar sigma 1 by n1 plus 1 by n2. Okay, now if in case 2, in another case, in case 2, if sigma 1 square is not equal to sigma 2 square and sigma 1 sigma 2 are not known and sample size is large, then we can say sigma 1 is equal to s1 and sigma 2 is equal to s2. Then for this particular condition we can write x1 bar minus x2 bar by s1 square by n1 plus s2 square by n2. Okay, next, and fifth step is what? Reject or do not reject the null hypothesis and conclusion. Okay, now solve the problem. So first problem is the average hourly wage of a sample of 150 150 workers in a plant A was rupees 2.5x. Okay, 2.56 rupees with a standard deviation of 1.08 rupees. Total number of worker for this particular plant A, it is 150 workers. Now in plant B, the average hourly wage of a sample of 200 workers, so 200 workers in plant B was rupees 2.87, was rupees 2.87 rupees with a standard deviation of rupees 1.28. Can an applicant safely assume that the hourly wages paid by the plant B are higher than those paid by plant A? Clear? Now the steps: parameter of interest mu1 and mu2, level of significant alpha assume 5%. Clear? Okay, now H0 null hypothesis is what? Mu1 is equal to mu2. Okay, so this is a plant 1, this is plant 2. Okay, and alternative, the question is, can an applicant safely assume that hourly wages paid by plant B are higher than those plant A? Okay, so mu1 is less than mu2. So here you have to use the left tail test. Now if the question is, if the mean wage is different, okay, or the difference of the mean wage is significant, then here we have to use alternative hypothesis not equal to. But the question is whether plant B, wage of plant B is more than plant A. That's why we have to use the left tail test. Clear? Then we have to calculate the Z-cal. So here formula is, it's very simple. It is given x1 bar, x2 bar, s1 square by n1, s2 square by n2. So x1 is what? 2.56 and x2 is 2.87. 1.08 square by 150 plus 1.28 square by 200 and value is minus 2.46. Clear? Now if alpha is here, alpha is equal to 5%. Okay, so it is minus 1.96 plus 1.96. This particular critical value is somewhere here. Okay, less than minus 1.96. So reject the null hypothesis. Okay, and reject the null hypothesis, that means was the difference is significant. The difference is mu2 is greater than mu1, or plant wage of plant B is more than wage of plant A. Average wage of plant B is more than average wage of plant A. Okay, next. In a certain factory, there are two independent processes manufacturing the same item. The average weight in a sample of 250 items. Second question. 250 items produced from one process is found to be 120 gram. Okay, so 120 gram with a standard deviation of 12 gram. So standard deviation of 12 gram. While the corresponding figure in a sample of 400 items from the other process are 120 gram. Okay, so 120 gram with standard deviation of 14 gram. Question is the difference, is this difference significant? Is this difference significant? Okay, now, and level of confidence, say level of significance, level of confidence is 99%. So level of confidence is 99%. That means alpha is equal to what? Alpha is equal to 1 minus alpha is equal to 0.99, means alpha is equal to 1%. Okay, level of confidence is 99%. So 100 minus alpha is equal to 99. So alpha is equal to what? It is 1%. That means 0.01. Okay. Null hypothesis, mu1 is equal to mu2, and alternative hypothesis, mu1 is not equal to mu2. Now Z calculate. It's a very simple. x1 bar, x2 bar, s1 square by n1 plus s2 square by n2. So 120 minus 122, 144 by 250 plus 196 by 400, and value is minus 1.9342. Okay, alpha is equal to 1%, that is 0.01. okay, so minus 2.58 critical region, critical value, and this particular value is somewhere here, minus 1.9342. so do not reject the null hypothesis. Okay, that means this difference, this weight difference is insignificant. Okay, now that is the end of this particular video. Thank you very much.